In this one, we'll be working through the odd number problems from the extension practice sheet. This is extension optional, not going to show up on the Power assignment, but it may show up on the portfolio, and it's just good information if you're going to be taking more classes in the future. Here we go. We want to evaluate the sum, in this case, of the first 50 terms of this sequence. So n over 2 times a1 plus an, but that we don't have. So we need to take a detour and calculate that an. Start by finding the formula for the sequence. That's going to be your first term plus your common difference times n minus 1. So for the 50th term, we want negative 4/3 plus 5/3 times 50 minus 1, so times 49. Run that through a calculator. Negative 4/3 plus 5/3 times 49. And turn that into a fraction. What I've got is 241 over 3. So when you want to turn things into a fraction, if you are on Desmos, let me just do that calculation one more time in Desmos. Plus 5/3 times 49. Notice it gives you the decimal. To turn it into a fraction, just hit the little button up here at the front, and it gives you the fraction version instead. On the TI calculator, anytime you want a fraction, if you got a decimal, just go into your math menu and choose this very first option, and then press enter. It'll turn it into a fraction for you. Okay, so coming back, I know now that my last term is the 241 over 3. So one last time, we'll run this all through the calculator. 25 times negative 4/3 plus 241/3 takes us to an overall sum of 1,975. So there you go. Same as what we did before. The only difference is that we have to do a little bit more work to find that last term. Let's go again. Well, I do mine. Let's have you do yours. We'll see if we end up in the same spot. Gonna now find that last term. Okay, so the 10th term. So 10 minus 1 is what gives us the 9. So that final term then is a 79. All right. And I hope that you ended up where I ended up at the 520 for the sum of those first 10 terms. Now in these next ones, it's essentially the same thing, just presented a little differently. We need to figure out the common difference this time as well. So from term to term, you just have to ask yourself, are we getting bigger or smaller? Well, these are going more negative, so getting smaller. And by how much? By 5 each time. So each time you go down by 5, there is your common difference. So we've got most of the information we need. We got a 12-term sum. The first term we have is right here at negative 17. What we don't have is the last term. So set up the formula for the sequence. The common difference, actually, because the common difference is negative, I'm going to write it as minus 5 times n minus 1. So in the case of the 12th term, 12 minus 1 would be 11. So negative 17 minus 55 gives me a 12th term of negative 72. That then means the sum of those first 12 terms is given by the expression here in blue. So run that through the calculator machine. We end up with a negative 534. So one additional step, right? Not only did we have to find the last term, we had to first find that common difference. But don't overcomplicate it. Just give things a look. You should be in a good shape. For this last one, do a quick pause. Unpause when you are ready to check. Notice here that each time we're going up by 2, up by 2. So there is your common difference. We're looking for the sum of the first 18 terms. So that's going to be 18 over 2 times the first term plus the last term. Let's figure out what that last term is. We've got a1 plus the common difference times n minus 1. I'm looking for the 18th term. 18 minus 1 would be 17. So this should end up being, I think, a 27. 18th term of 27, well, that's going to be 20. 20 times 9, this all ends up being a 180 overall. And there you have it. So if you're missing the first term or the last term or the common difference, you should be given enough information to reverse engineer it and figure that out to get all the information that you need. Notice now the difference, though, with this next set of questions. We are already being given the sum. It is our task to figure out how many terms were involved in the sum. This is a fairly straightforward algebra problem. You're going to fill in what you know and solve for what you don't. So the sum, which in this case is 520, is equal to the number of terms over 2. Well, I don't know the number of terms. Times the first term plus the last term. Fill in what you know so you can solve for what you don't. So let's see what we got. 520, I'm going to come over to the side here. So 520 equals 7 plus 97. That's 104. Now I'm going to take this 104 and divide it by the 2. So 52 times this n that I don't know. So to finish, divide both sides by 52. This is a 10-term sequence. Or series, rather, a 10-term series. All right, let's go again. Similar setup for the next. I know that the sum is 620. That's n over 2 times, we got the common difference this time, but not the last term. So we need to figure out that last term. Let's think here off to the side. My nth term is going to be 46 plus my common difference times n minus 1. Here's the thing, though. We don't actually know how many terms we have. So there's got to be an n that stays in here. Let's see what we got. So a sub n equals 46, distribute the 9, plus 9n minus 9. I'm going to combine the 46 and the minus 9 to get, what is 46 minus 9? 37 plus 9n. So come over here now, plus 37 plus 9n. So this is going to get a little bit interesting. Let's see what we have. So the 620 I'm going to leave alone. In here, let's do 46 plus 37 for a total of 83. And at this point, you have some choices. You can distribute the n over 2 through the parentheses. That will work. However, because these are both odd numbers in there, it is going to leave you with fractions in your parentheses. That's not wrong or necessarily even bad, but it does make things a little bit more complicated. That said, let's multiply both sides of the equation by 2. So over here, that's going to give me 1,240. And then over here, the divided by 2 just goes away. Distribute the n through the parentheses. So 83 times n plus 9n squared. This is a quadratic equation. So with that quadratic equation, to solve it, let's get everything on one side with a 0 on the other. I'm going to write this in the standard order. So how about a 9n squared plus 83n's plus 1,240. Now at this point, you got some choices. You can use a quadratic formula on this. You can factor this, but I don't have that kind of time. I'm going to graph this. So over to my Desmos, I'm going to graph y equals. Notice I'm putting in y equals and not 0 equals. The reason for that will become very clear here in a moment. 9n squared plus 83n. So 9n squared plus 83n plus 1240. Oops, it's minus 1240 though, right? So I hope you caught that. I tried to do a little too much work in my head. When you subtract that over, it would be a minus on the back. That's going to be a big, big important detail. All right, so let's see what we got. Now, it looks, doesn't it, almost like two straight vertical lines. It's really not. If we change the window a little bit, you'll see it actually is a parabola. If I go down to like, oh, that's not even far enough. There you go. You can kind of see the curve now if I set my lower limit super, super low. But really what I care about this time is what are my x-intercepts. There's one and there's one. Here's where context matters. What we're interested in is a number of terms. That means it's going to be a positive whole number. So this doesn't mean anything. This is where it's at. My solution this time is that n has to be 8. Okay. Next up. That's interesting. Didn't mean to do that, but tell you what, we're going to run with it. Okay, next up. Let's continue on. For this next one, we've got a similar situation. Now, it's presented differently, but notice we've got the same info as last time. I've got a first term. Our common difference this time is going to be a -3. And we don't have the last term. So I know the overall sum is number of terms over 2 times first term plus last term. But what's that last term? I don't know. Let's figure it out. So first term plus the common difference times n minus 1. Distribute the -3. The -14 and the +3 together. So that's going to be what? -11 minus 3n. So coming back over here, -11 minus 3n gets added on. I'm noticing what? That I have two like terms I can put together here. So -850 is n over 2, -25 minus 3n. Just like last time, because this is an odd number, I don't think I want to divide it by 2. So tell you what, let me move these out of the way for a moment. So instead, I'm going to multiply both sides by 2. That'll give me over here a -1700 equals. And then over here, distribute the n. -25n minus 3n squared. Quadratic equation, want to solve it again. I'm going to use graphing again because the numbers are big and I don't have that kind of time. So I'm going to add things over to the left side just to keep my n squareds positive. So 3n squared plus 25n minus 1,700 equals 0. Now I told you before that I put y equals instead of 0 equals. You can put 0 equals, and you're not even going to see much difference here. I take that back. I guess you are. Yeah, Desmos can't do that. But if you put the y in instead, it'll graph it and let you find those x-intercepts. So let's now put in our new version. The end of the second. And I've already forgotten what the rest is. Plus 25n minus 1700. Plus 25n minus 1700. And again, we are interested not in this negative answer, because our n is a number of terms. It's going to take us 20 terms to get that done and taken care of. So there we have it. And this time is 20. Now, when you get that answer, if it makes you feel better, by all means, double check it. Find the 20th term, calculate the sum, make sure it does come out to -850, which it will in this case. Okay, with these next, we're starting with the summation notation. So this is going to be similar to the last one and the one before it, although I'm going to say it's a little easier, because to find your first term, just put a 1 in here for the I. So 8 times 1 minus 15, that's -7. So the sum this time, 444, is equal to number of terms over 2 times -7. And now the last term is just 8n minus 15. Simplify in here. So 4 equals n over 2 times -7 minus 15. That's -22. Because these are both even, let's just distribute the n as it is. So 4 equals n over 2 times here. So the 8 and the 2 will reduce to 4, n to the second. The 22 and the 2 reduce to 11. Subtract the 444 over. And then let's see what we got. I'm going to once again use my graph to help me solve things out. So it's a 4n squared. And then minus 11n minus 444 minus 11n minus 444. Don't care about the negative one. I only want the positive whole number answer on the other side. So our number of terms this time ends up being 12. If you do ever get a result that isn't a positive whole number, that means you made a mistake somewhere. So go back, see if you can figure out where that error was. And then lastly, same idea. We've got the sum as we switch back to the pen. Equal to number of terms over 2. For the first term, put a 1 in. 18 minus 8 times 1, or sorry, 17 minus 8 times 1. That's 17 minus 8, which is 9. Put the n in. You got 17 minus 8n. A little bit of simplifying. The 9 and the 17 together will give us a 26. Distribute the n over 2. So that'd be what? 26 over 2 is 13. 8 over 2 is 4. I like to keep my n squareds positive, so I'm going to add and subtract over. So 4n squared minus 13n minus 705 equal to 0. Pull up my graph. 4n squared minus 13n minus 705. Looking again, I don't care about the negative side. I want the positive whole number answer on the other side, which comes out to be 15. So I just want to remind you, these are pretty tough. It's for that reason they're not going to show up on your power assignment, but it's not a bad skill to have. A little review on solving quadratics and making sure you can use that summation formula appropriately.